Hi, welcome back. This week we're going to talk about our new unit, which is on one of the more popular topics in statistics, and that is called the normal distribution. Normal distributions are very commonly occurring. When we collect data, we run into these very frequently. Normal distribution is basically a bell-shaped curve. It's symmetric with the peak in the middle, and it kind of tails off on both sides, makes a bell shape. When we collect data, we very frequently run into these things. And when we're dealing with these, it's a continuous curve, and we run into these when we're dealing with what we call continuous variables. And we've talked about continuous and discrete variables in class before. Remember, discrete variables were variables that typically hit on our counting numbers, our whole numbers, whereas continuous variables could hit on anything, all the decimals in between and whatnot. So when we're collecting data and we have a continuous variable, a lot of times we'll get a curve shape from our data, and the most commonly occurring curve that we'll run into is the normal distribution shape. This roundly peaked in the middle, symmetric distribution. And the good thing about that is, because it is so common, we can use this to make measurements of probabilities and predict how commonly things are going to occur. Typically, when we run into this bell-shaped distribution, we refer to it as normally distributed or approximately normally distributed. We'll get into some more of that terminology as we go. But when we refer to a normal distribution, we are basically talking about this bell-shaped type curve. Properties of the normal distribution. First off, as we said, it's symmetric in shape. The neat thing about it, the mean, the median, and the mode in a perfect situation. Now, sometimes it'll be very close to each other, but when we have a normal distribution, and it's truly a normal distribution, the mean, median, and mode will all be in the same location. They're all equal in value. If they're slightly off, you're going to not be quite perfectly normal with regard to the distribution. And if you remember, we've talked about how when we have a skewed set of data, we get the mean pulled in a direction away from the median. So when they're apart, that indicates that we have skewness in our distribution. So in the normal distribution, they'll all be located in the center. At that center peak is where everything is located, the mean, median, and mode. Anytime we refer to the distribution, the total area under that curve all adds up to be 1 or 100%. That'll come into play when we talk about probabilities. The area under the curve that lies within 1 standard deviation, and you kind of go 1 standard deviation above the mean, you can go 1 standard deviation below the mean. That value is always going to be 68%, or approximately 68%. If it's within 2 standard deviations of the mean, that's going to be 95%. So if we have data that falls within 2 standard deviations of the mean, we're including everything. We're going to include 95% of all the occurrences, I guess, is the best way to put that. If it's within 3 standard deviations, and I don't know if you can see that at the bottom of the screen or not, the area would be 0.997, which would be 99.7% of all the data that occurs is going to happen within 3 standard deviations of the mean in a normal distribution, which means it's almost impossible to go more than 3 standard deviations above or below the mean. So when we look at the graph, and I've kind of got one laid out for you here, you can see we go 1 standard deviation above and below this mean. This mean is the middle. Remember, mu is the symbol for the mean of a distribution. So if we go 1 standard deviation above and 1 standard deviation below that mean, we're going to have 68% of the data, roughly. If we go 2 standard deviations above, that's 2 this way and 2 that way, that's going to cover about 95% of the population distribution. And of course, like we said, if you go out 3 standard deviations, you can see that's going to be 99.7% of all the data is encompassed by those 3 standard deviations on either side of the mean. Now, how big the standard deviation can change, and we're going to talk about how to deal with that as we go, but we're always going to be able to relate to this concept that within 2 standard deviations, we have 95% of the data. Within 1 standard deviation, we're going to have roughly 68% of the data. Now, because of you'll remember we just said that the area underneath the curve was 1. We can always convert to what we call the standard normal distribution. And we'll talk about how we do that in a little bit. But when we talk about a standard normal distribution, we're converting whatever we have. Like we might have a mean of 500 with a standard deviation of 30 or something like that. We can always convert that to the standard normal distribution, which is a mean of 0 and a standard deviation of 1. And you'll understand why we do that in just a moment. We use this distribution after we convert to the standard normal distribution. We can always use the information that we know about the standard normal distribution to find the areas under the curve, which we use to estimate probabilities. We're going to do this using the z-score. Now, we talked about z-score. It's been a while now since we're dealing with everything else we've been dealing with this semester, but we have talked about z-score before. It's the measurement of how many standard deviations from the mean we are. The z-score identifies the number of standard deviations that a value is above or below the mean. And the way we get that is we use this formula, x minus mu, or whatever value we're dealing with, x, minus the mean, mu, divided by sigma, which is the standard deviation of our distribution. So we can always identify how many standard deviations we are from the mean by using this formula. And that's an important thing to know. We'll use the formula later. Right now we're gonna just start off. I'm gonna give you z because I don't even want to worry about that. We're gonna take the value z and then we'll come back and work with this formula later. But once we know the z-score, we can find the area that lies under the curve that relates to that z-score, and that tells us a little bit about the probabilities of things occurring. So what we're going to do is we're going to use this normal distribution table. If you look at the assignments that I included this week, or the list that I gave you in your Google Classroom, you will find a file on that Google Classroom entry that I gave you this morning that includes the normal distribution table. And I'll show you what that looks like here. It's labeled normal distribution table. It's a PDF, and it's going to look something like this. Now, what we can do is this, you'll see all these numbers, and I'm going to show you how to read this in just a moment. But what it's going to do is it's going to tell us the area that is laying underneath that curve behind some number that we find on that curve. So we might find a number over here that is our z, and then we'll find all the area to the left of that value. And knowing that area tells us the percentage of data that occurs in this section. Remember, it all adds up to be 100%. So if I can find that area underneath, that portion of the one hole that we have, that's going to tell me the probability that we have for that value that we're observing. Let's look at a couple of examples here, and maybe we can get into this. But what we're going to do whenever we find in this area, we might want to make a rough sketch of our distribution, kind of shade the area in question. If the shaded area that we're dealing with is less than a value that we're given or to the left of that value, we're always going to use the value that we get from the table. And this will make more sense to you in a moment, but if it's to the left, we're going to use the value given in the table. Like in a situation like this, we have a value, our z we found. In this case, it was a positive value because it's to the right of 0. But our area to the left is what we're concerned about finding. Like we might want to know what percent of the data came less than this value. Well, that means that we're going to take the value that we get from the table. Our z might be on this side. It might be negative, but we're still looking at the area to the left of that. And whenever we're looking to the area to the left, we're always going to use the value that is given to us in the table. If we're looking at an area that's to the right of our z value that we find, like in this case, I have a z value here, whatever it might be, and we're looking at all the values that are coming above that, or to the right of that, we're going to take the value that we get from the table, and we're going to subtract it from 1. Remember, the whole thing is 1, so if I tell you the area that's to the left, which is what the table is going to give you, the leftovers would be what's to the right, and in a problem like this, that would be what we're concerned with. So if we're looking for the area to the left, we're going to take the table value. If we're looking to the area to the right, we're going to take the value that we get from the table and subtract from 1. And if we're getting something between two values, like here, you'll see this first drawing here where we have the area between these two different z values that we got. If we're finding the area between two different z values, like here, or even this third one here, we're going to take the two values that we get from the table, and we're going to subtract them from one another. So you have three situations that you got to be aware of. If you're looking for numbers that are less than or to the left, you're going to take the value from the table. If you're looking for values to the right or above a value, you're going to take the value from the table and subtract from 1. And if you're looking between two values, you're going to look both of those values up in the table and subtract them. Okay, so let's look at some examples here. And I know some of this is all new to you, and I'm speaking a different language, and you're a little confused. So let me explain to you what we're talking about. So say we're going to find the area to the left of the z value of 2.06. So we have a graph here. I've kind of made a little sketch of the distribution. We have our normal distribution. Z of positive 2.06 will be over here to the right. And we're going to find the area to the left of that, all this area back here. So if you'll remember what I just kind of went through, we're going to look that value up in the table, and we're going to use that given area. So we'll go to, it was, I'm sorry, I just already kind of forgot. It was 2.06. So we're going to go to that value. We're going to find it in the table. And you can see here the values, the z values are going to be over here on this left-hand column. Now you'll see on the first side or the first page of the negative values, we're looking at positive 2.0. So we're going to go to 2.0, and let's see if I can fit the whole thing in here. So 2.0 is right here in this row, and we want to find 2.06. So we're going to go up here to we got 2.0 here, and we're going to go to 0.06. So we're going to go down this column, and we're going to go over this row, and we will see that our value is right here, 0.9803. Now what that is that is the value that is to the left of our z is 2.06. So our answer in this case, since we're looking for the area to the left, is that area is 0.9803. So what that means is 98.03% of all the data that occurs in this distribution is going to come in at a z-score lower than 2.06. And that is what we're going to do to make a prediction here, or find our probabilities from this. Okay, so again, that was to the left, so we just looked the value up in the table, and we went with it. My next example finds an area to the right. Now we're looking for an area to the right of negative 1.19. So again, and you know, the negative, positive doesn't have anything to do with left or right here, but here my negative value is going to be below 0. But we're trying to find the area to the right of our z value. So if you'll remember the rule I just kind of talked about, if we're finding the area to the right of our z value, we are going to look the value up in the table, and we are going to subtract from 1. So we're going to look up negative 1.19. Let's see if we can find negative 1.19. So again, we're going to where the negative values are. And let's see, negative 1.19 starts off with a negative 1.1, which is located right here towards the bottom of your screen. And we're going to go all the way over to this last column, which has the 0.09 section. And that is going to lead us to this value right here, -0.1170. Now, what we do, since we're finding the area to the right, is we're going to go to that 0.1170 that we got, and we're going to look that up, and we're going to subtract from 1 because we're finding the area to the right. In other words, we're looking for values that are greater than -1.19. So we're gonna take that and we subtract from 1 and we get 0.8830. So that basically means that 88.3% of all the occurrences in this distribution happen above -1.19, being the z. And we're going to find out how this applies to a lot of different situations as we move forward. But right now we kind of got to have a basic understanding of this z and what's going on with it. All right, third example. The area between z is 1.68 and z is -1.37. So here we are looking at an area coming between two z values. And if you remember, when I did that with you before, I went through the rule. If it was to the left, we use the value from the table. If our area is to the right, we take the value from the table, subtract from 1. If the area comes between two values, we're going to look both of those values up in the table, and we're going to subtract them from one another. So with that said, we're going to look up positive 1.68. So let's see if I can find 1.68. I know I'm kind of marking everything up. There's my 1.6. I'm going to use a red now. So we're at 1.6, and we want to find 1.68. So we'll go to the 0.08 column as well. So we're going all the way here and over from here. And there is my value for this 1.68. Now, that is basically 0.9535. Now, we're just going to take that 0.9535 and set it to the side for a moment. And then we're going to get our other value, which is -1.37. So let's get that. And -1.37 is going to be a negative value. So it's over here, -1.3. And the 7 column is going to be all the way out here and down here. Now, you don't have to mark this up every time. I'm just doing it so you can kind of get the process of what I'm doing and how I'm locating these values. So I've got 0.0853, and I've got my other value was 0.9535. So we're going to take those two values and we're going to subtract them. So again, we looked up 1.68, we got 0.9535. We looked up -1.37, we got 0.0853. So we subtract these two to find the area between them. So our area is 0.8682. Okay, so there you go, the three circumstances where we have to kind of know what's going on. Again, if it's to the left, we're going to take the value from the table. If it's to the right, we're going to take the value from the table and subtract from 1. And if it's between two values, we're going to look both of those values up in the table and subtract them from each other. So we're always getting a value from the table or doing something with a percentage from the table. We're either going to use it, we're going to subtract it from 1, or we're going to subtract it from another percentage. So let's take a second here, and I'm going to give you 3 problems to practice with. And what I'm going to do is I'm going to just let the video pause here, and I'm going to take a few seconds and let you answer these on your own. Now, just kind of reviewing real quickly our signs, this is z is less than 1.65, so less than, hopefully you would know the values are going to be less than to the left side. So I'm just going to let you think for a second about what that means. In number 2, we're looking at values that are greater than 1.91. Values greater than 1.91 are going to be to the right side of that 1.91. So hopefully you know what that means, and you'll think about that for a moment and know what to do there as well. And for number 3, we're actually our z value is actually between two numbers, and it's between 0, meaning it's greater than 0, but it's less than 2.32. It's coming between those two numbers. So hopefully you remember the rules we just discussed about what to do when we're looking at an area between two numbers. So take a moment and work those. If you're doing this on the Edpuzzle, it's going to ask you now. Okay, so for number 1, we looked at the area to the left of 1.65, and hopefully you remember that means we're going to use the value from the table. So we look up 1.65, and we take that value. It's 0.9505. Now remember, make sure you're looking at the positive 1.65, and that will give you 0.9505. Now, for number 2, we're going to look at the area to the right of 1.91. So that means that we're going to look up 1.91 and subtract our value that we get from the table from 1. So we'll look that up. You're going to get, 0.9719, I believe. And you'll subtract that out, and you get 0.0281. Now for number 3, you're going to look up the values for both 0 and 2.32, since we're going between those two numbers, and you're going to subtract them from one another. And in that case, when you look up 2.32, you get 0.9898, and when you look up 0, you get 0.5. So we subtract those, and we get 0.4898. So hopefully that's making some sense to you. You got 3 basic rules to use. We're always going to use the table that we have. Make sure you download that table in your notes, and you have that ready. If you have a printer and you can print one out, that's great. You don't have to, but it's very handy to kind of have. You can, if you don't want to use mine, you can probably do a Google search for an image and download a normal distribution table. They're very handy. Any statistics class is going to use these. All statistics books have them in there. You're gonna find a lot of uses for the normal distribution table here. So make sure you have that downloaded and you're ready to use it. Get some practice. I'll see you again. I'll be in class tomorrow, and we'll get some work done. And I want you to make sure you have a good day. Stay safe.